This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on zeros of polynomials. We've got a function f of x is x squared plus 2x minus 15. That is a polynomial. Remember, a polynomial is anything of the form a x to the n plus b x to the n minus 1 plus c x to the n minus 2 plus dot dot dot, etc. Coefficients are real numbers. Exponents are positive integers. We sum those and we have a polynomial. Now we're interested in the zeros of this function. Now what does that mean? A zero of a function is when the function crosses the x-axis. So you can see at this picture we have two zeros. The function crosses the x-axis here at 3 and here at -5. So this function has two zeros, one at 3, one at -5. Now we can actually identify that algebraically. So we can solve this equation and ask ourselves, when does this function equal 0? So we are looking at setting that function equal to 0. 0 is x squared plus 2x minus 15. Factoring that, we get 0 is x plus 5 times x minus 3. And remember, if two things multiply together to give us 0, either the first factor is 0 or the second factor is 0. So either x plus 5 is 0 or x minus 3 is 0. When you are solving a quadratic equation, it must be equal to 0. It's that 0 property that enables us to solve it. So x plus 5 is 0 or x minus 3 is 0. If x plus 5 is 0, adding -5 to both sides, x is -5. Adding 3 to both sides, x is 3. So those are the same two zeros that we saw before. Focusing on this, though, x plus 5 to the first power, x minus 3 to the first power, that's going to become relevant for us. So indeed, there is a 0 at 3. The function crosses the x-axis at 3, and it crosses the x-axis at -5. Now, we say both of these have multiplicity 1 because it's x plus 5 to the first power, x minus 3 to the first power. We'll look at some other examples where the multiplicities will be a little higher. So again, here's our conclusion. We started with this polynomial, x squared plus 2x minus 15. We have -5 as a 0 with multiplicity 1 because when we factored it, x plus 5 was just there once. 3 is a 0 of multiplicity 1 because when we factored it, x minus 3 was just there once. Well, if the 0 has a multiplicity of 1, the function pierces the axis. So notice this red curve actually penetrates, goes through the x-axis at -5 and at 3. That will be the case with all zeros of multiplicity 1. So here's our next example. G of x is x plus 4 times x minus 2 squared. So where are the zeros here? Where does the function cross the x-axis? Looking at our picture, we can see it crosses at -4 and it crosses at 2. That should not be surprising. -4 here corresponds to this x plus 4 equaling 0. That's multiplicity 1. Notice it penetrates the x-axis. But the other 0, which will correspond to when x minus 2 is 0 or when x is 2, that bounces. It hits 2 and then bounces back up. That corresponds to a 0 with multiplicity 2. So indeed, a 0 at -4 and 2, we would find that algebraically as follows. Setting the function equal to 0 to find out when the function crosses the x-axis, when the function equals 0. So of course x plus 4 is 0 or x minus 2 squared is 0, which will tell us x is -4 or x is 2. So those are the zeros as we saw with the graph, but talking about the multiplicity, -4 corresponds to multiplicity 1, 2 corresponds to multiplicity 2. And as I said before, -4 multiplicity of 1 goes through the x-axis. 2 is a 0 of multiplicity 2. Multiplicity of 2, it bounces. It is tangent to that graph. Let's take a look at another example. Here we're going to have f of x is 1/20th, x plus 1 squared, x minus 4 cubed, x minus 7. So if we want to think about what the zeros are, when does this function equal 0? What will the x values have to be for this to equal 0? Well, -1, 4, and 7. So how do we see -1, 4, and 7 in the graph of the function? -1 bounces. Well, why does it bounce? Because it's multiplicity 2. X minus 7 penetrates through it. Why does it do that? Because it's multiplicity 1. And x minus 4 to the third, that's 4, is a 0 of multiplicity 3. Notice it flattens out and then continues on. So that will be the behavior of zeros with multiplicity 3. So again, -1, 4, and 7 are our zeros, and there are your various multiplicities. -1 multiplicity 2, because of the second power here, 4 multiplicity 3, and 7 has multiplicity 1, x minus 7 to the first power. Okay, if we are going to look at a graph, how can we construct a function? So we're going to analyze those zeros and see what they tell us. So here's the information I have for this graph. We have a 0 at -4 and a 0 at 2. And we're also told that a point on the graph is 24. Each one of these zeros is a multiplicity 1 0 because the graph penetrates. It doesn't bounce, it doesn't flatten out. It penetrates the x-axis. So if that's the case, each one of these zeros will be a multiplicity 1 0. So we know that we're going to have x plus 4 somewhere. We know we're going to have x minus 2 somewhere to make those things zeros. So indeed, -4 is a 0 of multiplicity 1, 2 is a 0 of multiplicity 1. So to get a 0 of -4, I need x plus 4. To get a 0 of 2, I need x minus 2. But I don't know what the multiplier is. So I'm calling the multiplier z, and I want to find out what that multiplier will be, and that's going to require us to do a little bit of algebra. F of 0 is 24. Now we can certainly use that. Plugging in 0 plus 4 here, plugging in 0 minus 2 there. 0 plus 4 is 4, 0 minus 2 is -2. 4 times -2 is -8. That's the sort of thing we're going to use to help us find that multiplier z. So there is our f of x, and there is our f of 0 is 24. Plugging in 0 for x, z times 0 plus 4, 0 minus 2. 4 times -2 is -8. So I get f of 0 is z times -8. But I also have f of 0 is 24. So putting those together, 24 has to be z times -8. And if I divide both sides by -8, 24 divided by -8 will give me -3. So -3 is the multiplier. So I had this graph with this point a 0, this point a 0, and this point that enabled me to figure out the multiplier. Putting all that together, I'm going to plug the -3 in for z here, so that my answer is f of x is -3 times x plus 4 times x minus 2. So let's look at another example. We're going to look at a graph and try to construct a function for that graph. So we're given a point on the graph. We have a 0 here that bounces, so that tells us that will be in order 2, 0. A penetrating 0 here crosses here, that'll be order 1, multiplicity 1. And one here also multiplicity 1. So -2 has multiplicity 2 because it bounces. 5 has multiplicity 1 because it penetrates. 9 has multiplicity 1 because it penetrates. So how do I get a 0 of -2? How about x plus 2? How do I get a 0 of 5? How about x minus 5? 0 of 9, x minus 9. X plus 2 will have an exponent of 2 because it's got multiplicity 2. So indeed, x plus 2 squared for multiplicity 2, x minus 5 to the first, multiplicity 1, x minus 9 to the first, multiplicity 1. And I need to find the multiplier. I need to find z. I will get that by examining the point that we're given. So from the graph, we see that f of 0 is 5, and we should be able to plug 0 in for x to solve for z. So here's the information we have. So what is f of 0? Z times 0 plus 2 squared, 0 minus 5, 0 minus 9. 0 plus 2 squared, of course, is 4. 0 minus 5 is -9. 0 minus 9 is -9. 4 times -5, -20 times -9, 180. So f of 0 is 180z. F of 0 is also 5. So putting that together, we have 5 equals 180z. To solve for z, we've got to divide both sides by 180. 180z divided by 180 is just z. 5 divided by 180 is 1 over 36. So with that bit, we'll go ahead and put 1 over 36 in for z. So my f of x will be 1 over 36 times x plus 2 squared times x minus 5 times x minus 9. And we're able to get that function from the graph by analyzing the types of zeros of the function. Okay, let's take a look at one more. This thing has 2 zeros. We have a 0 here that penetrates, and then we have one here that flattens out at 4. If it flattens out, it is going to be a 0 of multiplicity 3. This one penetrates. This will be a 0 of multiplicity 1. So indeed, negative 2 is a 0 of multiplicity 1. If I want x to equal negative 2, that means x plus 2 is 0. So this is going to give me x plus 2 to the first power. 4 is a 0 of multiplicity 3. If I get x equals 4, that means x minus 4 is 0. I will need x minus 4 to the third power. So those are the two bits I have. Z, my multiplier, I don't know what that is. X plus 2 times x minus 4 to the third power. Now we're given this point on the graph. F of 0 is negative 4. So plugging in those values, plugging in 0 here and here, we can figure out what z is. So let's take a look at that. Looks like I put in a little here more than I wanted to. So let's go step by step through that process. F of 0, plugging in 0 for x, 0 plus 2 times 0 minus 4 to the third power. 0 minus 4 is negative 4. Negative 4 to the third power. Negative 4 times negative 4 is 16. Times negative 4 is negative 64. So I've got f of 0 is what? Is negative 128z. But we also knew that f of 0 was negative 4. We saw that earlier. So if f of 0 is negative 4 has to be negative 128z. There's your f of 0 is negative 4. So negative 4 divided by negative 128 is negative 128z divided by negative 128. And we get 1 over 32 equals z. So we're able to go ahead and place that z in here to say f of x equals 1 over 32 times x plus 2 times x minus 4 cubed. And that will conclude this lesson.